Good afternoon, everyone. Just letting everyone in here. All right, I'll get started with the introductions and we can let people in as they come in. Thank you, everyone, for joining us this afternoon. Just to make sure you're on the right webinar, we're here to talk about embodied carbon in public space design. I'll introduce our guests as well. And I'll put their bios in the chat so you can have a chance to have a deeper read in terms of the background. So today, we're really excited to have both Juliet and Colin here with us this afternoon. This interestingly started out as like a LinkedIn post. Like we were just talking about what are the gaps in sort of the whole carbon life cycle lens of a development. And as most of you know, we're quite focused on envelope and structure. We're starting to look more at MEP and interiors as well. We're like, what about outside the building? We started thinking, where are we with sort of public realm design? And I sort of asked the question. I got a few responses, and the ball got rolling. And we put Colin and Juliet together, and are really excited to see where this goes. I believe, and they can correct me if I'm wrong, but there seems to be, I think Zach's here as well. There seems to be interest in the city as well in this regard, in terms of having some requirements into the TGS in the near future. So this is really great. It goes beyond sort of whole building to whole development accountability for carbon. So this is really exciting to see. And been talking to more and more people about this as well, which is really exciting. Okay, so a bit of background. If this is your first time attending an event, we are the Carbon Leadership Forum, an international knowledge sharing enterprise. Started out as both a research and knowledge sharing group out of the University of Washington on the West Coast of the United States, and now has hubs all over the world. And we started this one in Toronto 3 years ago. If you're interested in getting involved, you can reach out through our email, and our website is at the bottom there, clftoronto.com. As a Toronto-based group, we acknowledge the land that we are meeting on is the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, and the Haudenosaunee, and the Wendat peoples, and is now home to many diverse First Nations, Inuit, and Métis peoples. We also acknowledge that Toronto is covered by Treaty 13 with the Mississaugas of the Credit. A little bit of marketing. So we have a couple of things coming up. We have first our submissions deadline for the Ontario Embodied Carbon Awards has been extended to this coming Friday. So if you have some time, sneak it in. Really excited. We just had the jury call earlier this morning to get started on this. So we're really excited to take this one on. The awards night will be in November. The date will be announced soon, sometime I think it's right in the middle of November, but the date and venue and all of that will be announced fairly soon. Also, our plug for an upcoming event. This one is in person. It is next Thursday, September, or 10 days away, 9 days away. Thursday, September 19th. It's in person at 165 Niagara Street. And we're going to be joined by Robert and Meredith here talking about deconstruction and material reuse. I think we might hear a little bit about some of the stuff in Colin and Juliet's discussion today as well. Okay, so some housekeeping. Please fire away with your questions in the chat. It sounds like we have about a half-hour presentation, so we should have plenty of time for questions thereafter. Recommend using speaker view. We also recommend you keep your audio and video off just to preserve bandwidth. And also this session is being recorded. And with that, I will pass it on to Juliet.
Thank you so much, Oscar. I'll just share my screen. Can everyone see my slide title deck? A nod, yes, from Colin. Great. So I see some familiar faces or names on the line. Nice to see you and meet everyone else. Thank you to the Carbon Leadership Forum for hosting this session. My name is Juliet Cook. I'm co-founder of Ha Climate Design, as well as a sessional lecturer at the University of Waterloo. And today I'll be discussing the role of embodied carbon in public space design, drawing from 3 of HAF's projects, the Bentway, Toronto's Urban Design Guidelines, and the Downsview Master Plan. not in that order, in fact. And so we'll explore how public spaces offer unique opportunities for carbon reduction, looking beyond just buildings. And so to date, part of what Alistair said in his introduction is that there's this kind of missing piece of the puzzle when we think of life cycle assessment, in particular embodied carbon. Public spaces have often been overlooked compared to buildings, but as we'll see, they hold significant potential for addressing climate challenges at the urban scale, particularly in their ability to store and sequester embodied carbon, while also offering other co-benefits. And so this kind of idea has really informed HAF's own mission and approach to work, where we foresee an industry shift towards increasingly regenerative and circular practices and design, not only in our buildings, but in their surrounding sites and infrastructure as well, where all of these strategies will hopefully inform more and more climate positive solutions. So shifting towards the right of this graphic, where we see a bigger proportion of green in that sequestration. And so first I'll be speaking to work that we did with the Bentway. This is about a year ago now. For anyone unfamiliar with the Bentway, this is the space underneath the Gardiner Expressway that's been activated for public use. The project already deals with a degree of reuse of urban infrastructure, namely the highway. And it has transformed this underutilized space beneath the highway into a vibrant public realm, fostering community engagement and providing a setting for arts, recreation, and other cultural events. And so HAF was brought on to understand the embodied carbon impacts of Bentway Phase 1 through life cycle assessment. And so we did this through the selection of these 3 sites that we're seeing on the slide. We chose to isolate these 3 representative chunks of the Bentway to develop more detailed understandings of the project's main drivers of upfront embodied carbon emissions. And so, in other words, we sought to understand the impacts from all the manufacturing, transport to site, and construction or installation of the materials used in these 3 sections of the Bentway Phase 1. Separate to this, we did also do an assessment of the highway itself, though these figures don't appear in the following slides that I'll present. And so we established per square meter impacts of the typical landscape details that are found across the project site. We ignored any buildings on the site. We really had a focus on landscape for this project. And so here we're seeing a few of the typical hardscape assemblies that exist. So concrete paving for pedestrians, vehicles, and then the refrigerated concrete paving. We then also expanded this to include more bio-based portions of the landscape. So here looking at typical decking, event stock, and the typical bioswale. And there are some others, but this just gives you an idea of how we establish the different layers of the assembly and associated embodied carbon data to each of those layers. When we get to the bio-based elements and including the wood decking, but also the soils, we also considered the biogenic carbon sequestration and the storage of carbon. And so the first bent that we examined, and the only one that I'll be speaking to specifically today, was bent 50 to 51. It has a landscape that is indicative of the typical softscape elements across the entire site, especially at the widest extents of the project, where much of the landscape extends beyond the drip line of the highway above, as we're seeing in this graphic. So beyond the embodied carbon intensities that we calculated, or the kg CO2 equivalent per square meter that I was presenting on the prior 2 slides, we also quantified just the percentage breakdown of softscape versus hardscape areas. Variation in the average intensity or carbon intensity represented the different conditions found across the site. So where there was lower average emissions, this was attributable to a greater proportion of green spaces, and the higher average emissions were attributable to more carbon intensive concrete-based hardscapes. And so in bent 50 to 51, which is illustrated here, the section's area is dominated by softscape in the form of lawn, seeded hillsides, tree plantings, and a bioswale, where of those softscapes, the clean fill was the highest upfront emissions in these areas, but where these soils also represent the majority of sequestration potential. And this is not even taking into account any other benefits from the softscapes to water management or ecosystem services. And the LCA tools that we use provide different ways of visualizing the data. So here we're seeing the relative impact of the specific materials that exist in bent 50 to 51. When it comes to the hardscapes of this study section, the key drivers were reinforced concrete and XPS insulation, both of which occur under the wood decking. So that was a bit of a learning on the project where we thought the wood decking might come out as a lower carbon, but because the assembly detail still had those materials, it actually ended up being one of the higher carbon intensive assemblies. And so it's really critical from that learning to consider alternative modes to founding the decking that still consider accessibility, but would reduce upfront emissions and increase the total area of porous landscape. And when we plot all the assembly types assessed across all 3 bench sites, here organized by hardscape to the left and softscape to the right, the question becomes, how do we shift designs, or at least the percentage of areas towards the right, where we're seeing less carbon intensive material as well as more sequestration potential. And finally, with this project, we also considered efforts to increase circularity in future bentway phases. I'll speak to one precedent that was discussed by Dirt Studio, where concrete slabs that you're seeing in the image here were reused in the landscape, effectively bringing the upfront emissions of these components to near zero. And this is just an image of the final landscape. And so individual projects like the Bentway are really important. However, we also need to apply these ideas at a larger scale. And this leads into the Downsview Master Plan project that we completed while the Bentway work was underway. And at the very start, I mean, the premise of the study was looking at right-of-ways and whether changing the right-of-ways or reducing the right-of-ways would reduce the embodied carbon of the new development. But specific to this presentation, we also wanted to understand what would happen to the increase in potential public realm that would occur as a result of these changes. And so we used a similar approach as the Bentway study. We isolated an area that we're seeing down at the south of the site here of the Downsview Master Plan to understand the impacts of changing right-of-way dimensions. For north-south avenues, we looked at reducing from 33 meters to 24 meters, from 4 lanes to 3 lanes of traffic. We eliminated the buffer between bike lanes and pedestrians and reduced the width of pedestrian zones to 2.8 meters. And the goal here was to have this avenue serve as more of a local road for both vehicles and cyclists, not the primary thoroughfare. And then in the east-west direction, we proposed a shift from 27 meters to 17.4 meters. And the intention here was that these lane streets would be lower traffic and bikes and cars could share the road access. And so we revised the massing and block structures of the current scheme to align with the curb cuts and property lines. We maintained the width of gaps between buildings. And so the resulting massings are in keeping with the overall vision of the current master plan. But by rethinking how we design streets and public spaces, so reducing car dependency, making more space for pedestrians and cyclists, we would not only be able to reduce carbon, but also create healthier and more adaptable urban environments. And so we kind of established the baseline metrics of the current design, and then compared this to the results from implementing those changes, namely increased floor area and green space on the interiors of blocks as to site. And so Downsview really demonstrated the potential for master planning where infrastructure, pathways, and landscape elements could be designed for lower carbon impact, where the public realm could serve both environmental and social goals. So we saw an increase in the amount of green space. We saw an increase as well in the amount of floor area and the addition of about 145 units with alongside that, the goal of assessing carbon, reduced embodied carbon per units as well. And so this project really demonstrates that master plans that take a long-term holistic view of development can help to inform designers and hopefully help to bubble up and inform guidelines that seek to achieve lower carbon designs across the whole city. And so this is where the challenge really lies, is applying these principles consistently throughout Toronto or the GTHA. And so this is where our work with the Toronto Urban Design Guidelines comes into play. These provide a potential framework to ensure that every public space project, regardless of scale, contributes to a lower carbon and sustainable urban environment. And so the Toronto Urban Design Guidelines, if you're not as familiar with these, are a framework that can help to systematize low carbon thinking across the city. How might the guidelines embed the principles of material reuse, sustainable sourcing, carbon sequestration into the development of public spaces throughout Toronto? And this is really critical to consider or think about as we face recent flooding events and more to come in the future, I'm sure. And so just speaking to the building side of this project before I get into the public realm, we assessed 10 projects across the city. We had 3 low-rise townhouse projects, 4 mid-rise, and 3 tall projects. And the core learning here was to understand the contributions of different parts of the building. So what was contributed by the below grade area, the ground floor commercial, if that existed in the project, and then the residential floors above. And so we worked through various ways of visualizing and understanding the different embodied carbon results that you can read the very wonderful study that came out of this project at more length. One drawing I'll call out specifically is this heat map where we looked at the impact of the different facade areas. So in terms of their carbon intensive nature. And so where the darker orange represents ones that are higher carbon and the lighter colors, the lower carbon assemblies. And when we get to the public realm, we conducted the analysis of all the public spaces for the 10 projects. In some cases, these were in the site, so we're kind of calling them pedestrian realm, as they're not always totally public. But we determined, or we wanted to determine the percentage distribution of impermeable, permeable, and vegetated areas in each, here denoted by the different colors that we're seeing on the graph. And so the low-rise and townhouse projects have the most softscaping, between about 25 to 30%, and have 5 to 10% permeable paving, while the mid-rise and tall buildings generally have between 85 and 100% impermeable hardscaping at the ground level. There were notable exceptions to this, being mid-4 and tall 1 on this graph. And so these projects are located outside of the downtown core, where building footprints typically occupy a larger share of the site area, which leaves less available for the pedestrian realm, whether hardscape or vegetated surface. And so it could also be surmised that low-rise projects have reduced areas of hardscape due to the fact that they may only need short paths to entrance doors or stairs, while mid-rise and tall building projects have requirements for increased areas of hardscape per current accessibility guidelines and to connect with immediately adjacent surfaces in the more developed city core. Impermeable hardscape assemblies not only have fewer environmental co-benefits, but also significantly higher embodied carbon intensities than do softscape and permeable surface types. And so we use typical assemblies that are specified in the City of Toronto standards for designing and constructing city infrastructure, as well as project-specific landscape drawing sets when we had them. And we calculated the A to C carbon intensity, so whole life carbon, ignoring any operational carbon, per square meter of groundscape. So exactly the same methodology as we did for the Bentway. And here just understanding per the different assemblies how they're performing. And so this graph is showing us to the left, the hardscapes typically are higher carbon intensity, driven by the orange poured concrete and asphalt, that lighter peach color concrete unit pavers, and then the lower carbon ones over on the softscape side of the graph. And in this case, we wanted to capture the B phase and C phase emissions, particularly the B phase emissions. So we're seeing the replacement of materials throughout the service period of the assessment. And so in a similar way to the heat map that we did for the facade of the buildings, we can apply that same kind of imagery to the landscapes, where on the original slide, we were just looking at the different percentage breakdown of the area of these different assemblies, hardscapes and softscapes. And here we're actually looking at the carbon intensive nature of them. So the hardscapes correlating to the darker oranges that are higher carbon, and the softscapes in the lighter colors. And so through these various projects, I hope that you have learned that public spaces hold untapped potential for addressing climate challenges. As with buildings, low carbon strategies, or lower carbons, or carbon reducing strategies, I should say, include incorporating bio-based materials, prioritizing reuse, designing for long-term durability, generally using less stuff. By focusing on the embodied carbon of materials and the potential for carbon sequestration in landscape design, public spaces could be transformed into carbon sinks. And public spaces can be leveraged as tools, not just for reducing emissions and sequestering carbon, as we've seen in the projects I presented, but also for building more resilient and socially beneficial environments where we can exist between the bands of the social foundations and the ecological ceilings as put forward by Rayworth in the concept of donut economics. Thank you for your time and attention. I'll look forward to any questions you have. I'll pass the mic to Colin, who will be speaking about site-specific interventions that effectively achieve low carbon goals.
Great. Thank you so much, Juliet. My name is Colin Berman, and I am an associate partner with DTH. I'm a landscape architect by trade, and I'm here today to give you the landscape architect's perspective on low carbon site design. So I just get myself organized here. Thank you. I'm passionate about sustainable design, landscape architecture, and I'm glad to have you here today. I'll share some insights about designing landscapes with the carbon lens and our work. As a firm, we're aiming to think about carbon in all of our work. As designers, I believe we all have a responsibility to take action and change the way that we practice going forward. As professionals in landscape architecture, we don't just shape public spaces. We have the opportunity to influence carbon reduction as well. Juliet emphasized the major strides that can be made through policy and master planning. But there's another way to address this issue at the site design level. Cities and developers are constantly building and rebuilding parks, streets, and public areas, and landscape architects play a vital role here. By focusing on our design choices, we can collectively help make a significant impact on reducing carbon emissions. Up until a few years ago, it was difficult for landscape architects to measure our carbon impacts. This lack of clear data made it challenging to fully understand the environmental consequences of our designs. As a result, many projects unintentionally contributed to climate change without a way to track or mitigate their carbon footprint. In 2019, a freely available tool designed specifically for landscape architects working on site design was introduced to the industry. This tool allows us to measure the carbon impacts of our projects, from materials to construction methods, as well as their potential for carbon sequestration. It also provides a way to compare different design strategies, helping us to make informed choices throughout the design process. It has become a powerful tool and has created a new lens through which we approach design. In the past, our design was primarily a creative response to a project brief and community input, focusing on aesthetics, function, cost, and technical feasibility. Now we have a new and crucial lens, carbon impact, that fundamentally reshapes the design process. This added perspective forces us to rethink how we approach materials and construction techniques, ensuring that environmental considerations are at the forefront of every decision. Our primary goal in applying a carbon lens to our work is to reduce the number of years it takes for the plants on a project to sequester the same amount of carbon that was used to build the place, or what we call a return to positive calculation. This is an easily understood idea. The less carbon we use on a project, the faster we can bring it back to carbon neutrality through sequestration. To reduce embodied carbon, we know that about 85% of emissions for an average landscape project come from materials. This is an area we look to improve during our design process. As Juliet put it at the master plan and policy level, we want to use less stuff. At the site design level, we want to use less carbon-intensive stuff. To sequester carbon, maximizing planting areas is essential. This is where landscape projects are unique compared to buildings or infrastructure, because outdoor spaces are living systems. Trees and plants in the landscape capture carbon from the air, which contributes to reducing atmospheric carbon, and they get better at it over time as they mature. This not only helps reverse climate change, but also offsets the carbon emissions generated during the construction of any given site. Let's look at this typical urban plaza, designed without considering its carbon impact. According to the Pathfinder tool, it would take a staggering 194 years for the plants in this space to sequester the same amount of carbon that was used to build the plaza. This is a clear example of how conventional design practices can contribute to long-term environmental challenges. Now, let's see how applying a climate-positive lens to the same urban plaza dramatically changes the outcome. By making a few key adjustments, such as converting 20% of the concrete paving to planting, adding 14 additional trees, changing some paving to crushed granite paving, and adding cement substitutes to site concrete, we have reduced the return to positive time to just 20 years. A remarkable change and a powerful story to tell a client and the public. In our work, we've been incorporating a carbon lens into our design process. I'll now share a recent example. This first project is a design competition for a new City of Toronto urban park at 229 Richmond, just east of John Street. Our park was called Embodied Garden, which in Anishinaabe translates as my grandmother. The open hand symbol in the park symbolizes our acceptance of the gifts we are offered and serves as a reminder of Nokomis, whose gentle hand guides the cycles of nature and life. Our design approach was defined and organized through an integrated central public art strategy, where the boundaries between landscape, architecture, ecology, and art are blurred. Our vision was to create a space that can be a place of learning, a place for ecological stewardship, and a place to meet, interact, and come together. Through landform, we fused an ecological strategy with a social strategy through the creation of exterior rooms, green sheltered walkways, windbreaks, and seating areas. We worked hard to peel back the hermetic surface of a typical plaza by integrating permeable paving into the site, achieving 87% permeable surfaces. The grading across the site is also important. It offers flood protection, not only here, but also in surrounding areas. Acting like a natural sponge, the site captures rainwater and helps recharge the aquifer. It will retain the first 20 millimeters of rainfall from storms, surpassing the City of Toronto's standard, which only requires 5 millimeters of retention. Our intertwined ecological and cultural design strategy was also underpinned by a robust carbon plan. We discovered that our initial design, straight from our first team workshops, would become climate positive after 1,200 years, which was unacceptable. This led us to explore alternatives. One key solution was repurposing existing materials. We considered how to manage the construction and demolition waste from the site. We also proposed to reuse asphalt and stone from nearby projects, keeping them out of the waste stream. This decision alone avoided around 475 tons of embodied carbon, significantly reducing our carbon impact. We also proposed low-carbon concrete pavers with 40% supplementary cementitious materials, which further cut emissions. Finally, we focused on increasing carbon sequestration by increasing the number of large trees, native plants, and by using biochar as a soil additive, which speeds plant growth and improves the soil's ability to sequester carbon. With these changes, we were able to reduce the years to positive time to 134 years from that initial 1,200, a remarkable change for an urban site. Through detailed design, we were confident that we could have reduced the time to climate positive to 5 to 10 years by exploring additional strategies, such as renewable energy generation and working with the city to implement better maintenance practices. This design competition taught us just how far we can push the design process towards carbon optimization by designing with a carbon lens from the very beginning. The next project is Cherry Street, Commissioner Street, and Don Roadway in the Portlands, a transformative project for our client, Waterfront Toronto. These streets are part of the larger revitalization of the Portlands. While we use the Pathfinder tool in other projects to calculate carbon impacts, this project is an example of how we can implement carbon-conscious principles without specific tools. These streets were designed with a deep commitment to reducing carbon emissions and sequestering carbon through the integration of vast areas of green infrastructure. Let's walk through the details of how we embedded carbon reduction into these urban streetscapes. Here, we see perspective renderings of each street: Cherry Street, Commissioner Street, and Don Roadway. What immediately stands out is the green character of these streets. We focused on integrating green infrastructure deeply throughout the design. Each street now incorporates features such as extensive tree plantings, bioswales, and permeable paving. This green infrastructure provides critical stormwater management benefits, reducing runoff, but equally important, it actively sequesters carbon over time. The design of these streets goes beyond function. It redefines how urban streets can contribute to carbon reduction. Here we see the space allocation graphs for each street, which illustrates a key feature of the design. Planting occupies a significant portion of the right-of-way. Much more space is dedicated to plants, pedestrians, cyclists, and transit compared to typical urban streets where vehicles dominate. I'd like to highlight that the vision for these green streets was established in planning policy, but it was the complicated work of landscape architects that took that high-level vision into reality. Through many rounds of complex, multi-stakeholder negotiations and city departmental consensus building, we brought these streets to life. It's one big step to set a vision for a low-carbon future, and it's another huge leap to actually build it. This is where landscape architects add tremendous value to the transition to low-carbon places. We figure out how to get it done. Let's now look at specific green infrastructure we implemented to achieve these goals. Open planters with soil cells and bioswales are two of the key green infrastructure strategies we integrated into the street. These systems are designed to capture and treat stormwater, providing important environmental benefits while also promoting carbon sequestration through healthy plant growth and improved soil conditions. Bringing these systems into technically complex urban streets required coordination across multiple city departments, utility providers, and stakeholders. It pushed the boundaries of what's possible when balancing green infrastructure with urban services. The scope of green infrastructure implemented here is the largest of its kind in the city. Grass swales, treed boulevards, and temporary meadows were also integrated into the project, with over 1,800 cubic meters of potential stormwater capture and over 2 hectares of vegetated space, including 480 trees. These elements represent a large-scale approach to carbon sequestration, embedded directly into our urban fabric. By treating stormwater and creating new green spaces, we've dramatically increased the ability of these streets to absorb and sequester carbon, far beyond what traditional urban streetscapes can achieve. These construction photos, though not final, show how these streets are already thriving. As the neighborhood continues to develop around them, the impact of the deep integration of green infrastructure will become even more visible. This project marks a significant step forward in how we design public spaces, positioning us to meet the challenges of climate change through thoughtful, carbon-conscious design. Let's now reflect on the lessons we've learned from incorporating these strategies into our work. We've adopted a series of strategies to prioritize carbon reduction when we design parks, streets, and public spaces. First, we focus on increasing planting, which enhances the site's carbon sequestration capacity. Reducing the extent of paved surfaces is another crucial step. We also take a thoughtful approach to materials, reducing the use of carbon-intensive products like plastics, steel, and concrete, and instead choosing natural or recycled materials. Avoiding overgrading is another critical practice, since excessive grading can release large amounts of carbon. By working with the natural topography, we help keep carbon in the soil. Controlling specifications helps us achieve the exact outcomes we aim for. And finally, we work with owners to find maintenance solutions to reduce the landscape's operational carbon impact. Altogether, these strategies form an effective toolkit for creating climate-friendly projects. Building on Juliette's ideas, we also know that a circular approach to design by reusing materials on site offers huge carbon benefits. However, it also comes with some design challenges. One of the biggest hurdles is the lack of control over these materials. Since reused materials often come from various sources, consistency is difficult to achieve. This can lead to unexpected results after being salvaged and stored, or when they arrive on the construction site, making the process less predictable. For designers who prefer precision and control, this can be a challenge. However, it also encourages flexibility in the design process. To manage this, prototyping is more important than ever, and detailed specifications are crucial when incorporating reused materials. Here you can see the entrance pavilion at Tommy Thompson Park, designed by DTAH. A unique feature of this project is the use of found objects from the spit, which were integrated directly into the building. By doing this, we reinforce the connection between the pavilion and its surroundings, while also embracing a low-carbon approach with material reuse. We've also learned to be assertive with product suppliers in the marketplace. I can't tell you the number of times I've told sales reps that we want to see environmental product declarations, or EPDs, for their product line. An EPD is a concise, standardized, third-party verified report which communicates clearly and without bias the environmental impact of a product or material over its lifetime. With this information, we as designers can make smarter decisions, considering not only how a product looks, but also its environmental impact compared to similar products. And we've seen the market respond. There are now many more companies that we work with regularly publishing EPDs. When we tell a sales rep that we won't spec their product unless we see an EPD, they perk up pretty quickly. I urge you to do the same with the sales reps that you work with, because the more we ask, the faster the market will respond. In every project, we aim to focus on carbon reduction, even when it's not an explicit part of the scope. Fortunately, this doesn't require much extra effort for landscape projects. We're already performing quantity takeoffs to calculate costs, and we can leverage that same data to easily produce carbon estimates using tools like Pathfinder. By integrating this into our existing process, we can provide valuable insights without adding much additional work. Viewing design through the lens of carbon reduction is a powerful approach, but how we communicate this to clients and the public is also crucial. Since clients often have different perspectives, it's important to present the carbon reduction story in a way that resonates with them. This is an important point, and I can't give you a one-size-fits-all answer. We at DTH have to think long and hard about each unique project and client to tailor the carbon narrative to them. Cost is also always a part of the conversation, but low carbon strategies don't always come with added costs, so it's important to communicate this too. Through experience, we're getting better at this, and you'll need to work on your projects or with your clients or consultants to find a way of telling the carbon story that works for you. Thank you for listening, and we'd be pleased to take questions and hear about your experiences in reducing carbon in your work.
Thank you, Colin. Thank you, Juliet. That was great. I mean, two really phenomenal bodies of work. I think hopefully for everyone, and we'll get to the questions, it kind of demonstrates how much work is being done in this area. This is not something that is you're not necessarily breaking new ground, as it were. You're really using the tools you have at hand. As Colin just said, you're using quantity takeoffs and things you're using for other purposes in a way to tell the kind of just sort of speak to the narrative around carbon. So let's get through some of the questions. I think, and Julia, thank you for answering some of these as well, but I think, the questions really, in buckets were, around tools, and then also around policy. Let's maybe starting with tools. It sounds like, one click is something that we use a fair bit on the building side. Pathfinder is perhaps a piece of software that is not as obvious to others. I don't either of you want to take that question in terms of what that works, how it works, is it similar? How does it work into your workflow?
Hey, Lena.
Colin?
How you doing? Listening to this.
So was that about Pathfinder?
Yes, yeah.
Yeah, and I think I provided a reasonable overview of how we work with Pathfinder in our workflow. We find it relatively seamless to integrate into, and it's important that we integrate carbon analysis from the very beginning of the projects. We find the outcomes are much more meaningful when we do that. And as you alluded to, we've also found that unfortunately, it's not a heck of a lot more work to do because we're already drawing numbers off of our design work. And the Pathfinder tool is created in such a way that it's easy to crunch the numbers using existing area takeoffs. It's not, looking at Juliet's work, it's not as precise. It's more of a broad strokes analysis than some of the precision that Juliet's team has been working with the Bentway on. But that level of precision isn't necessarily necessary at the conceptual design level for a site project. It's important that you understand the broad strokes of the impacts of the balance of hard versus soft space, the impacts of the material decisions that you're making to make those choices as early as possible in the design process. And you can optimize as you move through more detailed levels of design. And you can see that in our design competition project that I presented, that as we predicted that as we moved into detailed design, we could make further improvements as we began to study the assemblies and material makeup of the project.
It's really fascinating because it's sort of, again, it's like everything around carbon, it speaks to sort of a proactive approach, right? So this is really doing some of this work up front to help provide not necessarily a destination, but a vector in terms of where you can make some really smart decisions as far as your carbon accounting. There was a question around, and I think this was a good one from Brianne around assumed service space of a public space. We tend to use 60 for buildings. It sounds like a great place to start for when we're considering both things. From your perspective, Colin, when you're looking at time spans, when you're looking at the design competition and other case studies, when you're thinking of a time horizon, were you really just trying to get to the point where you were carbon positive, like in terms of, where those two lines intersected, or were you thinking of sort of a longer time horizon?
Yeah, so interestingly, the founders of the Pathfinder tool, there's a woman named Pamela Conrad, who's a practicing landscape architect in the United States, and there's a huge group of volunteers and practitioners that have developed this tool, and they actually created a challenge around the Pathfinder tool to challenge practitioners to have public spaces like urban plazas return to carbon neutral in a 10-year time frame, which is a hugely aspirational goal. But what that allowed them to do is create that challenge and crunch some numbers about what that would mean if our industry in North America all achieve these goals. The cumulative impact of landscape architects practicing would be enormous on a scale that has global significance. So we work to achieve those goals. We found in many of our projects where we're aiming for that 10-year return to positive time for urban places, we design a lot of urban parks. It's really difficult. Urban parks are typically like quite hard surface oriented places. So it's a challenging goal. We find most of our projects, if we get in the kind of 10 to 30 year time frame of reduced time to carbon neutrality, we're happy with that, and we get better as we progress through different phases of design.
Great. So there was another question here for you, Colin. In your opinion, how common is the use of LCA tools in landscape architecture practices? This wasn't as common, I would say, probably even 5 years ago, but what's the sort of sense right now from?
Yeah, the momentum is growing. I'm consistently surprised as I speak to other landscape architects across Canada. I do some volunteer work for the CSLA, so I'm in contact with people across the country. Not a small proportion of practitioners know about it. So doing webinars like this is really about spreading the word so that everybody jumps on board and starts using this. And I think when you get into it, as we've demonstrated, it's not, there's not a huge learning curve to it. It doesn't result in a lot of additional fees or additional costs for building, and it has a huge impact. So we're trying to spread the word where we can. The City of Toronto, I know I see Sonia on here with a question too. The City of Toronto is on the precipice of adopting the use of Pathfinder and a newer version of TGS, which will have a huge impact on the industry because it will obligate many more practitioners practicing in the City of Toronto to use it and really spread its impact. But looking to our neighbors to the south, the American Society of Landscape Architects are doing a much better job of publicizing this to industry practitioners, but that is having a pretty significant ripple effect to us as well. Juliet, I'm curious about your perspective on that too, to see any other LCA tools that you use and or the Pathfinder.
Yeah, so we're familiar with Pathfinder. We know Pamela Conrad. In fact, one point with Shayna on the call, we were maybe going to be working all together, and hopefully that'll come about in the future. But I think, Pathfinder to all the projects that Colin spoke to, is really wonderful it's very intuitive as a tool, and it's really great visualizing not only like where the product sits, but that time scale of showing you where you become climate positive. And it's really useful for that. I think we typically will use it in those earlier phases, concepts, especially. with something like the Bentway, even Downsview, well, Downsview less so, but with the Bentway, this was a postmortem assessment, and we had specific assembly drawings that were given to us, and we did want a bit more specificity in terms of the environmental product declarations that we were using. If that achieves any more accuracy in the results, that's what we were really going for, because we had that level of information provided to us. And so that's why we use something like One-Click. But One-Click LCA has other visualizations that it provides, that tree map, for example, that I showed, less to do with the kind of big picture. It is primarily building focused. And so even with some of the EPDs that we selected, it may not have been the most perfect, exactly what was specified in the assembly, but it was the best matching one, and one that didn't exist in Pathfinder, for example. So that's why we went with that tool, because of the drawings that were provided to us and where the project was at in its timeline. And then for Downsview, where we were at an earlier level, we just sort of used the results from Bentway and other projects where we've done public realm as part of the scope, to assume those numbers, and just applied it to the areas of the project. But I think the way we approach it in buildings right now is that we use certain tools early phase design, where it's thinking about more formal questions and general number of stories, is there below grade, that sort of thing. And then as we move through design development and CDs, and we have that layer of detail, then we can move to tools that have more, it's larger databases perhaps, but also more control over which materials you're applying to different parts of your assemblies.
For the both of you, I guess a question would be around, and Colin, you mentioned EPDs and sometimes the difficulties in sourcing them for specific materials. If you were to take, a landscape project spec today, as a percentage, how much of that do you think has EPDs available? Is it still in its infancy, or is quite a bit, it sounds like the other side of it, which is what we just spoke about, which was you build up a database internally, right, to benchmark, and then you sort of leverage that. But that's sort of within the organization you're in or clients you're working for. For those who haven't got into it or are on the call here and things like that, I think it would be really interesting to understand how do we then build up a database, so that yes, you have to measure to manage, but then it's like, now that I've got a data set, how do I know what this is relative to other data sets? I wonder if you could speak to that a little bit in terms of what's available and how challenging that's been.
Yeah, I think the market is still in its infancy, at least I'm speaking specifically to landscape architectural projects. So we're looking at things like pavers and site furnishings and other typical off-the-shelf projects we would use in parks and public spaces. And there's probably 20% of the stuff that we use has EPDs available to it. I mentioned to every sales rep that we speak to that you folks have to get going on this, and we do give them an ultimatum. We say, we're not going to use your product. We can't compare it to product B. In the old days, we would just select a bench based on the one that we like looked the best. Now we're selecting it on aesthetics as well as its environmental impact or performance. So there's some leaders that have jumped out ahead in the industry too. There's a Scandinavian site furnishing manufacturer called Vestor that's making some really incredible strides in terms of their manufacturing process and using low carbon steel and publishing and being transparent about all the results. That's setting a really high benchmark for other site furnishing manufacturers to follow. The one that I used in the presentation was from Meglin, a Canadian company. They hired a dedicated sustainability person on their team and have now started to publish because more and more professionals have prodded them. But we maintain a database in the firm of low carbon products. It's a struggle because it's ever changing, and some of it, there's different standards for EPDs. There's a European standard, I can't remember the acronym right now, and then there's a North American standard, which is EPD. Sometimes it's not always comparing to apples, so as the kind of ground level practitioner or design consultant, it can sometimes be difficult to navigate those different methodologies. So it's a constant learning process for us, but we do try and maintain a database of materials so that we are not searching things anew for each individual project, and we have some level of consistency in the organization across the firm. Juliette?
Yeah, well, I think, my well, the bulk of the work that we do at HAF really focuses on buildings, but inevitably, as you continue to push, okay, the site of the building and then beyond the site of the building to public realm, as we're talking about today, we're going to have to begin to quantify all of this. And I think what the work Colin presented is, showing single firm that's doing this. I'm sure others similarly doing the same kind of work, and the kind of next step. So internally creating a database. I think what's really great about everything Colin presented also is that it's not necessarily right now about going for a certain certification or doing like your whole landscape assessment, which is important, but really just as designers in our day-to-day like design decisions, how we can demystify and start using these tools to inform those decisions. So maybe, if we're thinking of it from the building perspective, it can sometimes feel a little bit daunting to go and do a whole building LCA. So similarly, like a whole landscape LCA might feel a little daunting, but if you're using the tool at different stages to compare between different assemblies or different products, that's where there's a lot of power for us as designers in those, like along the way. I think in terms of building the databases, I think internally setting some benchmarks is great. Right now, we don't really have targets that are mandated or let alone even exist. And then add similar again with how buildings conversation has gone, perhaps some benchmarking study is required, like the cities of Vancouver and Toronto have done, to understand where things kind of currently sit. And then that can help to inform targets that more people will have to actually achieve. But right now, anyone who's a practitioner can start to do this kind of work just so internally we're setting those or gaining an understanding about where that practice sits. I think what will be really critical and what was sort of brought up by Brianne's question is how we're then standardizing and aligning on assumptions like service period, methodologies more generally, what EPDs might be being used. And so some of that is still kind of ill-defined even on the building side, but something to also consider as we try to move towards anything where we'll be comparing results from different firms.
Yeah, I mean, it sort of leads well into the question that, Sonia has asked here. Zach's here. I think Lisa's here as well. In terms of when we often talk about policy, we talk about sort of the carrot approach and then the stick approach in terms of the incentives that exist out there to start taking this on. Eventually we're going to get to a point where there will sort of come the stick approach in terms of, thou shalt do so, if not, suffer the consequences. But in the time as we're building up, it sounds like a benchmarking, study, not dissimilar to that buildings might be sort of areas to start. But I think, as we're wrapping up here, I would say, I think we're really open to how, and again, Colin, through your work across the country, through CSLA, even down in the States, if you're seeing things that are incentives, Lisa and I always talk about this in terms of what can we learn from other jurisdictions? How can we incentivize these things? How could we help push this forward? I think the city of Toronto is definitely on board, but they're always open to ideas and suggestions and how we could really activate and spark more of this in the industry. I think it starts, I would say, first of all, with people like yourselves who are not just willing to do the work, but also willing to share it. That is really, honestly, actually, it's a massive hurdle that we find at the CLF is finding people who are willing to share what they've learned is really important. I think it also puts your names and your practices out there in terms of resources of people to reach out to. I think that's really great. And so that's really fascinating. There's one last question we will sneak in. On the subject of whole building LCA, Adaptas is capable of doing that LCA as well as identify materials for reuse. Adaptas is a sort of software that's used for whole carbon accounting as well, which can inform these sorts of landscape designs that include reuse materials, potentially overcoming some of the roadblocks mentioned. What sort of drivers have you seen for building developers to reuse materials beyond experimental projects? So yeah, this is again, like, what are the carrots? What are the incentives out there to actually reuse materials? We know in Europe they have sort of strict. They've moved to the stick approach, where they're actually mandating percentage material reuse. Landscape, I think, is a fantastic place. You saw that in the Tommy Thompson one as well, where you can do so. We're going to see it live when we're visiting Rob and the gang at Taz in a week or two as well. But yeah, curious to hear your sort of final thoughts before we wrap up on how building material reuse in the public realm could really be sort of yet another area of untapped potential.
I mean, I'll just go quickly and say that Colin's project, the DTAH project down at Tommy Thompson, Alistair just mentioned the work that Taz is doing. I think what landscape offers a really unique opportunity where some of the performance of salvage materials that gets called into question when you're trying to reuse it in a building where it might not be possible if something can't be recertified as structural, or it's not good cladding material anymore, can actually be reused in a landscape design with that kind of circumventing those challenges, those performance challenges. So I think we've seen a lot of successful examples of that happening. And just calling out that Adapt is, yes, familiar with the tool and it's great. I'm curious to know a bit more about whether they, like, the extent of their focus on public realm right now. It seems, my understanding has been it's very focused on buildings as well. But yeah, I think in terms of quantifying the benefits of it, often if you're reusing something from a building that was on a site and you're reusing it on site, like, what are the cost implications as well? So how might you be saving on costs? And often when there's a dollar sign reduction, the carbon piece, they go hand in hand, and then the client or whoever is making decisions is more convinced by it. So that's always great to see. And then I think there's the whole like narrative and storytelling piece to it. So if you are reusing something that has been salvaged from the site itself or from nearby sites, if you can, especially somewhere like the Bentway, for example, where you could have a story about the reuse, I think it will be really compelling. It'll be a whole activation that contributes to the community and to the kind of cultural event side of a space like that.
Yeah, I think from the landscape side too, we're just at the very beginning of we're just scratching the surface of exploring material reuse in public spaces. It is truly just kind of bespoke, unique projects that are doing it now. But I imagine a future where in 10 or 20 years from now, every time we see an RFP call from a municipality or a public body, material reuse is a part of the project. And circular economy is a part of the thinking from the very, very beginning. We relax our kind of very colonial Victorian expectations of having perfect, pristine, artistically designed spaces, and we start to really dig into how do we reuse the things that we've already extracted from the earth. I think that future's coming, and we all have to work hard together to get there.
It's the perfect place to end. Thank you both, Colin, Juliette, for your time, for your presentations. Thank you all for attending this afternoon. Have yourselves a great rest of the week.
Thanks, everybody. Please reach out
Bye.
if you have any further questions.